Welcome to Homework Lib.
So the magnetic field between two conductors is only due to the current flowing through the inner conductor. So from Ampere's law for the circular path, we know that the loop integration of B dot dr is equal to mu naught I end enclosed. So from there we know, and also we know that I enclosed is equal to I here, and the integration is equal to b times dr, which is the circumference, so 2 pi r. So from there we can write b times 2 pi r is equal to mu naught I, or b is equal to mu naught I by 2 pi r. For part B, the energy density of the magnetic field is given by U is equal to V squared by 2 mu naught. So for a small cylindrical shell with a thickness dr and inner radius r and length L, so we have the thickness thickness dr, inner radius r, and length L. The volume element will be dV, which is equal to 2 pi r L dr. And the reason for that is because what we're doing here is we are trying to calculate the volume element of this part. So this ring-like thickness is dr and the inner radius is r. So we have 2 pi r as the inner circumference, and we multiply that with the length L, and then we multiply that with dr, or the thickness, which gives us the volume element dV. So once we know dV, we know that the energy stored in this thin cylindrical shell will be du, which is equal to little u times dV, which is equal to v squared by 2 mu naught 2 pi r L dr. Now if we substitute the expression for B, which we got from the previous part, we have du equals to 1 over 2 mu naught, then mu naught I divided by 2 pi r, put a square there, times 2 pi r L dr, which is equal to mu naught I squared L dr. Divide that by 4 pi r. So that's the energy stored in this thin shell. So now in part C, we have to calculate the total energy stored between the two conductors. So all we have to do is we have to take the integration of this small energy element du. So from A to B, we have mu naught I squared L by 4 pi r dr. So if we now do the integration, we can take the constant outside. So we have mu naught I squared L divided by 4 pi. Then we're left with dr over r, and the integration limits are from A to B. So now using the limits and solving for the integration, we have mu naught I squared L divided by 4, sorry, that's going to be pi log base E B over A. So where A is the inner radius and B is the outer radius. So this is the energy stored between the two conductors. Now for the final part, we have u, which is equal to Li squared by 2. Now also from the previous calculation, we know that this is equal to mu naught I squared LdR. Divide that by 4 pi, sorry. So this gives us L is equal to mu naught L divided by 2 pi log base E B over A. And as we can see here that this is the same result as obtained in the previous problems. All right, thanks for watching. I'll see you next time.